Let's talk about this problem over here. It's 2001 AMC 12, problem 18. A circle centered at A with a radius of 1 and a circle centered at B with a radius of 4 are externally tangent. A third circle is tangent to the first two and to one of their common external tangents as shown. What is the radius of the third circle? So the radius of the third circle is basically this. It's basically this part here, right? So let's figure that out. So that kind of looks confusing. So when we face this type of problem with a lot of tangents and circles, we connect. So a useful strategy is we start connecting the centers, and also the tangent points to the centers. For example, A to this tangent point, that's a right angle. The center, let's just call it C. C. This is going to be a right angle. B down. This is going to be a right angle, right? And then we connect A and C. So another useful strategy is if we just, so we start from a center, right? And then you just draw this line that's parallel to the tangent line that these three circles have in common, like that. And then we know that this side here is just gonna be 4 minus the radius. Let's just call the radius R. So this is R. Right, 4 minus R then. Okay, and then basically, you can also do that with the center A. We know the radius of circle A already. That's just 1. So this part is gonna be 3 because that's just 4 minus 1. So that's 3. Okay, so what else can we get? Oh, okay, so this part is this part here is gonna be 1 minus R because, well, the part below is R and the whole length of the radius is 1, so this is 1 minus R. So let's just start. So how do we actually start? Well, we start by figuring out the the side lengths. So the relationship between certain side lengths. So we're going to use the Pythagorean theorem here because we have a lot of right triangles. So let's just start with this right triangle here. Okay, so let's just call this side X. So this is X also. This is Y. So this is Y also. And then we know that for the first relationship, we have 1 minus R squared, that's one leg, plus X squared, that's another leg, is equal to AC. So AC is just going to be the sum of the two radii, which is going to be 1 plus R squared. This, if we expand it, gives us 1 minus 2R plus R squared plus X squared equals 1 plus 2R plus R squared. Then if we just subtract 1 plus 2R from both sides, we have X squared is equal to 4R. X is going to be equal to 2 root R. Okay, so just remember this, or I guess jot it down somewhere, because it's important. Like, it's actually important. Okay, so on to the next part, the next triangle. The next triangle, let's just use this triangle over here. So, for that triangle, we have one leg is Y, so we have Y squared. The other leg is 4 minus R, so we have 4 minus R squared. And then the hypotenuse is just the two radii summed, which is 4 plus R squared. So this is Y squared plus 16 minus 8R plus R squared equals 16 minus AR plus R squared. Oh wait, plus AR plus R squared. If you minus 16 and R squared from both sides, you know that Y squared is equal to 16R. Y is therefore equal to 4 root R. Just remember this. Now we can do another final triangle. So this triangle here. Now we know that so one leg will be 3, so 3 squared, plus the other leg is just going to be x plus y. That's x plus y squared. The hypotenuse is going to be 1 plus 4, which is 5 squared. So we have 9 plus, so we substitute 2 root r and 4 root r in. We have 6 root r squared, which is 36r, equals to 25. So 36r is equals to 16, and r is equal to 4 over 9. So problem solved. The key here is to choose the right lines to connect and also choose the right triangles. So thanks for watching.